Okay, we are ready to finish this 1-4 lesson. This is part 2 of the lesson video. I mentioned earlier on your vocabulary portion of the notes that when two angles are supplementary, we can say that one angle is the complement of the other. Or if we say two are supplementary, we can say that one is the supplement of the other. So in example 2, when it says find the complement of angle F, really what we're trying to say is what angle would be complementary with F? What angle could we have so that that measure plus 59 degrees are going to add up to have a sum of 90 degrees, because that's what complementary means, is that they add up to 90 degrees. Well, the way that we can do that is by really working backwards and subtracting. So if we subtract 59 degrees, then we find that the complement of 59 degrees is 31 degrees. So if it says find the complement of angle F, the complement of angle F is 31 degrees, because 31 degrees and 59 degrees add up to 90. Similarly, if it says find the supplement of angle G, I'm looking for what angle can I add to 7x plus 10 to get 180 degrees, since supplementary means they add up to 180. We would use the same process here. We would work backwards and use subtraction, but the thing is we are actually subtracting an expression and not just a number. So we would need to do 180 minus all of 7x plus 10. Once you put those parentheses around that expression, it means that we're not only subtracting 7x, but we're also subtracting 10. So I would have 180 minus 7x minus 10, which would then simplify to 170 minus 10. I'm sorry, no. That would be 170 minus 7x. I already used the minus 10. We can't solve for x here because we don't have anything to set that equal to. We do know that this expression plus something equals 180, but we don't know what that something is. So we do not have enough information in this problem to figure out what x equals. So we can simply leave our answer as an expression. Notice that our original angle was an expression and our answer was also an expression. In the first example up here, the original angle was a degree measure and the complement is a degree measure as well. So that's a good indication of what your answer should look like. You should look at your original angle to see what your answer should look like. Should it have x's in it, variables, or should it not? In example 3, we're finding the complement of angle E, and this time angle E is an expression. So again, I'm saying angle E, which is 7x minus 12, plus what is going to add up to 90 degrees, since I'm looking for the complement. I need to subtract this entire expression from 90 degrees. So that would look like 90 minus 7x minus 12 in its entirety, which would simplify to 90 minus 7x plus 12. Because if I distribute that -1, it's a negative times a negative, which gives me a plus 12. And that expression will actually simplify to 102 minus 7x. And that's the expression that we have for the complement of angle E. Again, angle E was represented as an expression, and so is its complement. They both have x's in their answer. Find the supplement of angle F if the measure of angle F is 116.5 degrees. Supplementary means to add up to 180, so we're saying 116.5 degrees plus what will add up to 180. Again, we take our value, 180 in this case because we're looking at supplementary angles, and we subtract the angle that we have to figure out that our supplement here will be 63.5 degrees. So that's how we find the complement and the supplement of an angle. We either subtract from 90 or we subtract from 180, depending on whether or not it's complementary or supplementary. And also, our answer is going to reflect what our original angle was. If our original angle was simply a number, then our answer will be a number. If our original angle was an expression with a variable in it, then our answer will also be an expression with a variable in it. Let me go ahead and erase this before we move on to the rest of the page. I will tell you that we are coming up on some problems here that are expressed as words. So we're going to have to put those into algebraic expressions to figure out exactly what it is we're looking for. In example 4, we have an angle is 10 degrees more than 3 times the measure of its complement. Find the measure of its complement. I don't know what the original angle is, and I don't know what the complement is. So let's define a few things first. I'm going to say that my missing angle is going to be represented by the variable x. If that's the case, then the complement can be represented by 90 minus x. Just like in our examples up above, if we're trying to find the complement of something, we do 90 minus that value. So here we can say the complement of whatever this missing angle is 90 minus that value, whatever it is. Now we look at our expression and we say an angle is, we already said our missing angle is x, so we can say x is, or x equals 3 times 10 degrees more than 10 degrees more than 3 times the measure of its complement. Well, we defined the complement as 90 minus x. So we read that expression again. An angle is, the missing angle is x. So the angle is 10 degrees more than, which is plus, 3 times the complement, which is 90 minus whatever that angle is. And this is actually an equation that we can solve. We'll start by distributing. That'll give us x equals 10 plus 270 minus 3x. If I add 3x to both sides, then I get 4x, and if I combine 10 and 270, I get 280. So if I divide both sides by 4, then I actually find that x is 70. Now what is 70? X, remember, represents our missing angle. So our missing angle has a degree measure of 70 degrees. But this problem says find the measure of its complement. So if I have just found that the missing angle is 70 degrees, then the complement is actually 90 minus that 70 degrees. So our final answer is that the complement is 20 degrees. I want you to try example 5 on your own. Define your variables like I did here. Decide what your missing angle will be called, and decide in this problem what your supplement will be called. And use that to write your equation based on the words that you have. You will then have an equation that you can solve and figure out both what the original angle measure is and what the supplement is in example number 5. The last example that we have here, example number 6, is to name the pairs of vertical angles as well as to name the pairs of adjacent angles. Remember, vertical angles only share a vertex and they are directly across from each other. So this first angle over here can be expressed as angle HML. Pair that with the angle across from it sharing that same vertex, and that would be angle JMK. So angle HML on the left and angle JMK on the right are vertical angles. But that's not the only pair. We have another pair of angles that are directly across from each other that also share the vertex of M. It would be this angle right here and the one directly across and below it. This angle on top would be angle HMJ, and the angle on the bottom here would be angle LMK. That pair of angles, because they share a vertex and because they are directly across from each other, would be another pair of vertical angles. Lastly, let's use this picture to name just one pair of vertical angles. I'm sorry, not vertical, adjacent. To name just one pair of adjacent angles. Remember, if you look back at your definition, adjacent angles are angles that share a vertex, they share a common side, which is a ray, and they don't share any interior points. So one example could be this angle HMJ and this angle here JMK. Those two angles together share a side, and they also share a vertex. This is just one pair of angles. There are other pairs of adjacent angles on this picture. So I will say angle HMJ and angle JMK are adjacent angles. But I would also like you to use this diagram to figure out another pair of adjacent angles. There are actually 4 total pairs on this picture, so come up with just one more. When you come into class on Monday, you need to have example 5 attempted, and you need to have another pair of adjacent angles listed from this diagram in order to get full credit for having watched these notes.